My name's Nick Hewson. I'm head of product development at Viridi. So we're a New South Wales-based manufacturer specialising in timber construction. We have the ability to make lightweight wall, floor, roof framing, as well as bring in mass timber from external suppliers. We have a number of unique products that we're developing for the market, including timber concrete composite floors and reinforced glulam. So, there's a range of products that we can bring to the market, and we package that all up with a very robust design offering as well. So really trying to bring to the market a kind of wide range of timber focused solutions so that we can kind of hone in on a optimized solution for a particular project. So we're not wedded to one particular construction type or another, but we can be very flexible. My background is a structural engineer. I've sort of dealt in all materials over my career, but I have a particular passion for timber. But I think it's about using the right material for the right job. Every material has its inherent strengths and weaknesses, and by leveraging those, we can develop optimized solutions for a project. I'd love to see as much timber as I can in a project, but even the purest timber building still needs steel for screws and brackets. Still most likely has a concrete ground floor slab. Like every building is a hybrid, so every material has its place. And I think we're going to start to see more hybrid construction as we move into the next few decades.
And you mentioned there that you use a wide variety of products, and people listening now, you were the head of design for 5 years at Excellent. So coming from a mass timber background and moving into including more and more products, I guess, is in your toolkit. So what's just on that, like what sort of tools are the best for the right purpose, I guess, is what I want to sort of speak a bit about today. So moving with, I guess, starting with light frame walls is something that we've seen a bit of in Australia, but where do you see that right now and some of the advantages of using light frame walls?
So as I said earlier, our business has a capability in lightweight framing, and I think my background in mass timber has shown me there are a lot of benefits of CLT and glulam and LVL for structures, but certainly for low to mid-rise, there's a lot of extra material in there that's not necessarily doing a lot structurally. You don't tend to need a CLT wall in a building if it's 3 stories or below. It's a lot of extra material, a lot of extra processing for something that could be a lot lighter. So I think we sort of see some really strong advantages in using lightweight framing for particularly low to mid-rise, for schools, apartment buildings, areas where more heavyweight structures are probably a bit of overkill, a bit expensive. Particularly the sort of inner suburb apartments, schools is another huge opportunity. There's not many schools that are built over about 3 stories these days. So the utilizing that material, getting the most out of each stick of timber is important. Not only from a cost perspective, but also looking at using our natural resources more efficiently. There's a limited supply of timber out there, as we've seen. Certainly the last 12 months in Australia and globally has shown that the timber supply chain is not a quick beast to be able to scale up and down. It's very hard to suddenly grow 30-year-old trees in a matter of months to scale up production. So, what is the best use of each bit of fibre from a tree that we can get, and then in that low to mid-rise, that's more often than not going to be lightweight frame.
And do you think if we're saving on material as much as we can and doing things as efficient as possible, that the age-old question. I mean, can you do it more cost efficiently than traditional construction, or is that maybe the wrong question that we should be asking?
I absolutely think you can do it more cost effectively. I think certainly as we're making more trends towards prefabrication, doing things off-site, we know that site work is inherently slow. It's inherently difficult to control quality. If we can take more of that off-site, then we can build faster and we can therefore build cheaper.
So building lightweight timber walls in the factory, what sort of level of prefabrication can you achieve in the factory now? And I guess we can expand that question to different products as well.
So that we'll look to do as much in the factory as we can. The more that we can offer, the more that we can do under the factory roof, the better I think the product outcome is for the client. We can do everything from an open wall frame, which is just nailing together the frame to pre-installing structural sheathing, plasterboard, cladding, building wrap, insulation, to including windows and door installations. So I think being able to kind of offer that is really important. It's really goes a long way towards speeding up things on site, giving greater cost certainty to clients up front. But it also can improve quality. I think some of the challenges that we certainly find at the moment is that the more and more you prefabricate, the more that the interfaces and joints start to become tricky. It's very difficult to make connections between parts of structure when everything's kind of clad and fully finished. So we're certainly doing some innovating in that space and some heavy research in that area. But yeah, we look to prefabricate as much as we can, purely because it's faster and better quality.
Yeah, absolutely. So looking at different types of buildings, so say you got class 2 or class 5 buildings, differentiating them, what are some of the key design challenges for the different types of buildings, and what sort of systems do you think have made sense in the past, and what are we sort of evolving to as well as we go forward? There's a lot in that question, Nick. Sorry.
Yeah, well, I'll break that into a couple. Look, for class 2 buildings, apartments, I think the biggest challenges are that we're finding at the moment is probably acoustics, with fire as a secondary aspect. So we have a timber concrete composite floor system that we've developed that's called Strong Floor, which is it's like a metal deck and glulam bottom plate that goes to site and has a concrete layer cast on top, and it's got a very high level of fire and acoustic performance with it. But when we go into apartments, we have to put a lot more control around acoustic performance. Acoustic flanking across party wall lines is a big challenge to try to mitigate against. How we detail services and balconies, set downs for wet areas, set downs at balconies become quite challenging. I think there's a lot of components that go into make your average residential building, and there's a lot of kind of interface points throughout the structure, throughout the building facade, that all need careful care and attention to be able to resolve. Certainly, fire resistance is a much easier one to do these days. If you're cladding, if you're looking to expose timber, then that can become a challenge from a regulatory perspective, whether it's convincing fire engineers or building certifiers or the fire brigade of the robustness of the overall building performance in a fire is something we often get caught up in. It's a lot of it's a relatively new way of building to a lot of people, and that that rightly brings a kind of degree of scrutiny, and that's something that we spend a lot of time working through with designers to try to come up with systems that are robust. When it comes to kind of school buildings and offices and frame buildings, I think the challenges change a little bit. They are after more flexibility, typically in the building layouts, more open plans. So the structure may change from potentially being kind of load bearing walls to post and beam construction with glulam or LVL or even kind of steelwork. The challenges there are kind of more around fire, particularly spread of fire is seeing a lot of research in the last few years. We're building ever larger and larger buildings out of timber, but we don't have a huge amount of data yet on the performance of fires. So in a typical timber office with a large exposed timber soffit, exposed beams and columns, like how does the fire really perform? So how quickly does it spread? How does the building react? What happens if the facade breaks, and kind of how does it spread between floors? Issues like delamination of CLT have kind of been a conversation topic in the industry for the last few years. I think those aspects are very, very tricky to resolve. They're tricky to calculate. Certainly the research that's coming out in the last sort of 6 to 12 months has gone a long way towards answering some of those questions, but there's still a lot more to be done. There's still a kind of degree of nervousness from certifiers and from fire engineers. I think personally, I think there's enough evidence there to be able to calculate the performance and give a very robust sort of solution. It just needs a specialist group of people involved. It needs fire engineers who are experienced in this. It needs suppliers who understand the nuance of the details and things like that. It's not a case of calculating a fire resistance level and putting it at that. I think we've probably done a disservice to ourselves in the industry in some ways, in that we've often described timber in kind of crude terms. The timber burns, it chars and it insulates itself, so therefore it's great. It's true, it does do all those things, but when it comes to the performance of a building, there's more than just fire resistance levels to consider. And I think that argument, that discussion has got a lot more nuanced in the last 2 to 3 years, and I think we're sort of forging new grounds at the moment in terms of understanding and testing.
Absolutely. And you mentioned a few issues there. So compliance, acoustics, fire are all unique challenges in themselves. Looking at hybrid systems, or maybe differentiating hybrid buildings, how can different products combine to solve these issues and get the flexibility and, say, let's just tackle office buildings for a start, to get what's required for those buildings?
I think there are a number of inherent advantages of every material. Timber is a wonderfully aesthetic product. It's got tremendous sustainability credentials, but it does suffer from the fact that it's combustible. So, can we do something to the material to improve that? Now, that could be impregnation of sort of fire retardant chemicals. It could be incorporating timber with other materials. So we have a timber concrete composite floor system which we've worked hard to develop, which we see as a potential option for commercial buildings because it gives you the kind of timber feel, it gives you the look on the ceiling, gives you that kind of performance, gives you some of those sustainability benefits, but it has that concrete layer on top, which is performing together with the timber in a structural sense. But in a fire, the timber kind of functions more like fire protection in a way to the concrete. So once the timber's all burnt away, you're still left with a concrete slab, which can still do, which still has enough structural capacity left in that to remain standing. So that's been one area in timber buildings where people have kind of struggled with talk of self-extinguishment and burnout of compartments. So what happens to a timber building in a fire? If your structure is also combustible, does the fire get down to a level where it's no longer hot enough to sustain combustion and the timber goes out? It's an extraordinarily difficult thing to try to demonstrate, and depending on how you set up the experiments, you can show it'll do very well, or you can show it'll do quite badly. But how does that scale up to full scale structures? But using timber concrete composites, we can kind of take that element out of the equation, because we've got the timber in there for a lot of its benefits, but in a fire condition, it's not necessarily required. So we can then allow that to burn out and keep the compartment safe. So that's just one way that hybrid materials can help mitigate. So as we go taller, we start to find limitations around material strengths. You could continue to make timber columns bigger and bigger, but at some point, you start to get to a size that's uneconomic. There's not much sense having meter columns in a building. You're starting to lose too much floor area. So can you reinforce them? Can you supplement them with steel or concrete or some other materials to help bolster that capacity? I think we're seeing certainly some of the taller towers that are getting built at the moment. I'm thinking of the likes of Ho in Vienna with steel timber hybrid columns that work in parallel to take those loads and not celebrate some of the benefits of timber, but supplement it where it starts to struggle. So I think as we start to go higher and higher, I see more and more hybrid buildings. That is, a combination of timber and steel and concrete. We start to see more and more hybrid building products as well. So I think the level of interest in timber has been really, really high the last few years, particularly from a sustainability perspective. So we're starting to see timber being driven into more high-rise buildings now, and I think that the overwhelming majority of them are hybrid to some degree or another.
Do you think that timber finding a home in, say, high-rise buildings where you've got typical floors as you go up, so from a manufacturing point of view, you're pretty happy about that? Is it in a sense what you were saying before, where as a hybrid system, your timber works as a pretty much protection of the structure, and works in service case, but in the fire case, it's assumed to burn out? Or what sort of ways do you think, where is timber going to find a home in, say, 30, 40, or even higher buildings?
I think look, there's certainly an interest in trying to get as much timber in as makes sense. So whether it is a hybrid timber concrete floor system, whether it's a reinforced beam or column, or there's not a lot of limitations on the structure of the floor, I suppose, in many ways. You don't, the floor spans don't change the higher up the building you get typically. So what works on level 1 should work on level 40. I think where it starts to get a little bit trickier in the really tall buildings is when you look at earthquakes and diaphragm action of your floor. it probably makes people feel a little bit more comfortable to have something like concrete in there, because that's what they're used to, and that works very, very well. So that's one potential aspect as you go higher. I think the Atlassian Tower in Sydney had a fairly unique response to building high rise in timber, and I think that was kind of predicated by the kind of site and having to kind of build the structure in a very specific way. But what they've ended up doing there is they have a kind of series of mega floors, which occur every sort of 5 or 6 floors, which are a large steel and concrete floor system, which functions a bit like a transfer back to some large mega columns. And then on each of those, they then build a 3 or 4 story timber building. So they kind of sit there on a shelf in a way, so you're not limited by the strength of the timber. The fire aspect is kind of controlled on a kind of, I think they call them habitats or something, so on each kind of 5 or 6 story level, there's a kind of natural fire break with the mega floors, so they kind of create a way of building high without building high in a way. It's quite a clever solution, and I expect to see that sort of something like that, maybe start to take off in high rise, where we start to compartment the building into certain levels, and we deal with compartments within those, but then a sort of mega compartment which looks to contain fire and things like that in within a certain area, while they so they can stage evacuations and things. And it's I see a lot of innovations in that space starting to kind of see more and more timber in high rise.
Well, there's certainly a lot happening right now. It's an exciting future. What do you see as the future of timber or hybrid buildings and hybrid systems in 5-10 years? Where do you see it going? Everything.
I see a lot of opportunity. I think we've still barely begun to scratch the surface of what timber can do. I think we're seeing timber kind of start to eke into the mainstream with projects like Atlassian. I think up until now, while there've been some incredible buildings built out of timber, we're not really tapped into the mainstream construction market. We're still a very niche area, but I like to see kind of greater awareness and acceptance of timber in all building types, and that may well come through a kind of hybridized approach, where we're not necessarily going full on mass timber for 95% of the structural components, but we start to bring it in on projects, or whether it's a floor system, whether it's columns or beams or something. We start to kind of get more familiarity in the market, more market acceptance, more skills developed from designers through to installers and builders to understand that it's a beautiful material that can be part of almost any structure, but it needs a certain kind of understanding to design it, a certain kind of understanding to build it, that I think is still developing in the market. I think as we see more and more clients start to become aware about embodied carbon, I think there's a huge opportunity out there. I think the last 12 months, I think, has accelerated a change that I've seen coming, but the last 12 months has really picked up. The number of clients that are now want sustainable structures. They want to be able to offset the carbon in their structure. They're asking the right questions. Whereas a decade ago, sustainability was great, but only if it was cheaper. Now clients are coming to us with it at the top of their agenda. They're like, we want a kind of net zero building. We want to use timber. We want want to offset as much carbon as we can. We're prepared to pay a slight premium for it if necessary, but this is the top of our list. And Atlassian is probably a prime example of that, where they've optimized the structure around embodied carbon. Set themselves some tough benchmarks to hit, and I think more and more clients are starting to do that. You're starting to see people, investment portfolios and things, people starting to pull out of carbon intensive businesses. So many businesses have committed to net zero carbon. I think that's almost becoming a given now for a lot of big multinationals. They've now got a few years to start to work out how to do it, and I think a lot of them are going to turn to materials like timber, like hybrid construction, to try to get as much carbon out of their materials and to make their buildings as sustainable as possible.
Wonderful. That's a fantastic note to end on. Nick, it's been a pleasure to get to speak to you. If people want to find out more about yourself and what you do, where should they go?
You can look me up, Nick Hewson, on LinkedIn, or go through the Viridi Group website and see more of what we're doing.